Good morning, everyone. Over here, we have Tom van Leeuwen. He's the product manager of Waylay, and he will discuss the missing IoT link to scalable smart maintenance. Welcome, Tom.
Thanks, Jörg. Hello, folks. Good morning. Today, I'm going to talk about scalable smart maintenance. And the word scalable is key here in this sentence. Which is going to be, I'm going to talk about how to use automation to process your remote asset data that is IoT enabled, and then of course how to manage that business logic, right? And specifically how to leverage the knowledge that exists within your company, within the different stakeholders of your company, in a scalable way, such that you can quickly get your return on investment with respect to your IoT investments. So my plan is to go through a few introduction slides just to sketch the context. But my plan is also in this short presentation to also give you a bit of a demo of the Waylay platform as well, so that you get a bit of a feel of what the platform is about. We have, of course, much more information. So in case you have particular questions or comments, feel free to post them here in the Q&A session, or if you want to send them afterwards to me, it's also possible to tom@waylay.io. Maybe just to sketch a bit the context, there's a lot of talk about IoT and how IoT will actually enable new business models that require some sort of enhanced monitoring of your assets and coupling those monitoring services with some sort of outcome-based service contract. What does that mean? Well, basically, what we see across our customer base is that a lot of our customers are moving towards some sort of asset as a service, where a customer has, for example, a usage-based contract that allows him to use the asset, for example, a diesel engine, for example, for a predefined number of machine hours. And as part of those contracts, often there's some sort of performance guarantees associated with that, such that the end customer is actually guaranteed of a well-performing asset or machine. And if that's not the case, that either gets a rebate on the contract, but definitely he gets a superior customer service, because the monitoring tools are basically monitoring constantly the performance of your asset and will fix any issues before the end customer really even notices them. Okay, so that's a bit the dramatic shift that we see in the industry, and that's at least a promise. But how do we actually realize that promise? I think a lot of our customers are still struggling with that, or at least making the first steps towards that. And with the Waylay platform, we can really help them to achieve this. Now, what was also quite surprising from a survey from Plant Engineering magazine last year is that even today, a lot of the downtime in manufacturing plants is actually due to equipment condition or maintenance issues. So not only the new, let's say, new business opportunities or new business models are a driver, but I think there's also an important driver that is related to the current inefficient maintenance schedules that are being used to maintain remote equipment. And as you can see, 77% of the downtime could have been prevented using a smart and scalable remote maintenance solution. So how do we realize this now? So if I look at our customers when in their road to IoT maturity, as I call it here, they often start with what I call the connect and collect strategy, figuring out which hardware sensors and actuators to connect to their industrial assets, for example, and then bringing often that data to the cloud for being able to remotely visualize the performance measurements of your assets. So often people start with some simple dashboarding and alarming, but that's not what I call efficient and scalable smart maintenance. Usually it starts with that, but then people move over to enabling the rest of the organization, the other stakeholders within the company, to also come with use cases related to the data that is being gathered. And one of these stakeholders is, of course, the maintenance teams, which we will dive into more today, right? And we have a lot of customers that are indeed ultimately moving to as a service business model. But as you can see here in this maturity curve, there's a lot of ducks that need to be put in a row before you can actually reach that business model in an efficient way. So remote monitoring is the first step, but definitely once you start scaling up, automation is key, right? Automation in the sense of automated processing of the asset data, managing the logic that is associated with those automation rules, and then using them for the different stakeholders within your organization, whether that's marketing, whether that's product management, but definitely when it comes to field support and the maintenance teams. Okay, why automation? I think it's clear that automation in this solution plays an important role, but just to make it a little bit more tangible, ultimately what we want to do is decrease the cost of machine inspection when it comes to smart maintenance. Costs are related to inefficient dispatching of your field crew, but it also has to do with some maybe some not so obvious challenges that are actually quite common these days. A lot of the assets that our customers are monitoring are actually inaccessible. Either they are behind closed fences where only highly specialized personnel can access. Sometimes they are your assets are actually spread around when you're talking about large building complexes and your assets are in different parts of that building. Sending crew to the wrong part of that building complex is actually quite expensive because they lose time in finding these assets. And now, of course, with COVID-19, a lot of the end customers don't want external personnel to come on their premises, right? So in that sense, the fact that assets are not as accessible as they used to be is definitely one of the drivers to invest into remote and smart maintenance. Now, what we also see is that, especially in the industrial market, is that a lot of the personnel are kind of getting of a certain age, right? It's true that a lot of our customers are having some trouble to basically hire new qualified engineers, and they also often use outsourced resources in order to perform their maintenance, and these can be, of course, have varying quality levels with respect to their background knowledge of the products. Now, products themselves are also becoming quite technical and quite advanced, right? So there's an increase in hyper specialization required, especially with newer breeds of equipment and assets, and of course that requires again a high investment in training your people and your personnel. So automation can again here play an important role in the sense that it can help the inspection engineers, whether they're outsourced or whether they are junior, to help them to correctly identify and diagnose any issues with the product. And of course, if you are using an automated system that constantly monitors the equipment, you can create rules and business logic that generates recommended intervention actions for these people, such that they focus on the right problem first, and basically save time on site. The third challenge that we have seen with our customers is that in some areas or some markets, the inventory of what customers are running in terms of the type of asset, but definitely also the bill of material is somewhat out of date with respect to the inventory that our customers are maintaining. Something that can even aggravate the problem is that some end customers are actually replacing parts of the asset with parts from unapproved suppliers. So in that sense, when a field engineer comes on site to perform maintenance, often what they are confronted with is a bill of material that is not in sync with what is the reality at the end customer site. So these are kind of the challenges that Waylay tries to address using its IoT automation platform. Just to give a very concrete example, so once you are convinced that automation is the key, you of course need a platform that is capable of dealing with the reality in the field. And the reality in the field is often that a lot of our customers have quite a number of different versions of their product. They have a broad range of portfolio assets that need to be monitored, and they all have their own different settings. They all have their own different, I would say, settings that have to do with the customer environment in which they are deployed. So customer settings. And this here, for example, shows one of our customers that is in the valve business, where you can see that they have different types of valves being used in quite a number of different markets. Okay, so as you can imagine, if you are deploying a smart maintenance solution that is monitoring these type of devices, you have to be able to do this in a scalable way, in the sense that you have to be able to tweak and tune your rules depending on the varying portfolio that you have as a customer or as a production company. So how do you manage this in an efficient way, and how do you specifically leverage the knowledge that exists with your maintenance crew, because they know how these machines are working in the field. They often have knowledge in their heads, but not yet automated, that you should be able to leverage and do that in a quick way, I would say. So in order to do that, what we see with our customers is that you cannot always rely on R&D or the IT department to implement these rules. There are different stakeholders that have their own automation needs. We've already talked about the technician, the field engineers that know based on experience on how the asset or the machine needs to work, depending on the type, etc. But you also have different stakeholders within a company like, for example, data scientists who can build algorithms that can generate, for example, anomaly detection use cases that they would like to put into production as quickly as possible. You also have end customers themselves that may require them to tweak and tune rules for themselves. For example, if a notification needs to be sent towards specific people within an organization, well, the end customer typically wants to configure that themselves. And some end customers have their own intellectual property with respect to their production plant, for example, where they are looking for a solution to be able to put their own rules into production. Okay, so if all of those requirements have to be implemented by R&D and IT, they are becoming a bottleneck with respect to speed of deployment, right? So in other words, you really need a solution that allows all of these stakeholders to work together in an efficient way, in a safe way, to be able to speed up your rate of innovation, your rate of deploying new use cases, retire use cases that are not relevant, test out new use cases, perform A/B testing, etc. And that's exactly what Waylay offers as a platform. So how does Waylay now actually approach this problem? So today in this presentation, we will highlight one key feature, which is the low-code rule designer. This is something that is actually very hot these days in the IT domain, but it's now becoming also very important in the OT domain and IoT in general, I would say. So what is a low-code application? Well, it basically means that you can use, for example, the Waylay rule designer without having to have any knowledge of JavaScript or Java or database scripts, etc. You can just drag and drop your different business logic onto a canvas and build an end-to-end use case within a matter of minutes. Okay, and then of course you want to test that and validate that and so forth, and that's what the Waylay low-code rule designer offers. So in that sense, IT and R&D kind of become responsible for the framework, but it is ultimately the business analysts, the domain experts, the field engineers that can go into this tool and build rules themselves, and in that sense can actually speed up the release cycle of the different rules that they maintain. So you give a little bit of ownership and responsibility back to the individual stakeholders, and in that sense you can basically speed up the deployment of your use cases. Okay, so let's make it a little bit more concrete right now. So what I'm going to do is I'm going to show you the Waylay platform through the administrator console. So this is how our latest version of our Waylay console is looking like. So this is a front end typically for users of the platform that allows you to explore what data is available on the platform in the time series database, for example. But you can also start creating rules, right? And that's what I want to do here right now. So what I just opened here is what we call a rule designer, which is our low-code rule designer that allows you to create use cases via dragging and dropping a lot of data processing nodes here that we have in our library. So all of this is available into our platform. You can extend it with your own custom logic as well. But ultimately, what I wanted to show here is a kind of a simple rule where you chain a number of these data processing blocks together. So imagine we have an industrial machine that is sending, for example, temperature and pressure values, and you basically want to monitor those values to see whether those values fall within acceptable ranges. Okay. So what I'm defining here, for example, is a first input node that is going to pick out the pressure values that we will be shooting into the platform. And I'm wiring that together with a function node, and this function node is going to evaluate for the last 5 samples what is the standard deviation. Okay, so if that standard deviation is higher than 5, which basically means that you have a lot of fluctuation in the pressure, then that's obviously not a very good situation, and you want to raise an alarm for that, where I'm just putting here standard deviation is too high, it's a critical alarm, and the alarm type that we will generate is STD alarm. Okay, so once you have created your first prototype, you can actually now test it as well onto the Waylay platform. And for that, we have a labs tool, which you can use to simulate, for example, your engine. So here, I've already set up my simulator. I have a test resource, which could be our engine. It's going to send some temperature and pressure values. I added some randomness, such that there's some random values that are being used here for temperature and pressure. And I'm going to send this data every 2 seconds to the Waylay rule engine. So let me start this right now. So as you can see here on the right-hand side, this is the data that we are shooting in for this particular resource. Then here we can actually start our rule. So I'm going to start our rule in reactive mode and basically put it onto our test resource that we just created using labs. And let me start this rule right now. And what you can see is that the rule is being executed as data is coming in. So you can actually live monitor what this rule is doing, and also in the log files you can actually see how, for example, the function node is evaluating the standard deviation of the measurements. As I mentioned earlier, if the standard deviation is too high, we will actually generate an alarm, and you can actually see here when the state changes when the alarm is actually generated. Okay, so let's have a look at the alarms that are available here. There we go. So we have already a number of alarms that have been generated. So this is something that just happened, where you can see that it's very easy to evaluate your rule and update your rule on the fly here using this low-code designer. All right, I'm gonna stop here with respect to the demo. There's of course a lot more features in the Waylay platform that are available. You can use machine learning algorithms as well and instrument those. Well, let me quickly show that how you can do that. For example, I have a very simple rule here that applies a machine learning algorithm on bearing data, so bearing ball data with respect to vibration of these bearings, and apply a bring your own ML prediction algorithm to that, process that algorithm, and then generate alarms or print something on the screen here. So you can easily instrument trained algorithms here as well using our rule designer. So this is kind of an example how a business analyst that needs to know when alarms are generated on what needs to happen with those alarms. For example, create a ticket in Salesforce, for example. And on the other hand, your data scientist who can create these algorithms and basically instantiate those onto the Waylay platform. So this is kind of easy, and how you can actually use this rule designer to create your end-to-end scenarios without having to write one line of code. Okay. So just to wrap up this presentation, with the Waylay platform, you can actually create your use cases and applications 10 times faster than what you can do today. For example, with Java code or with database scripts. It's also much easier to monitor your rules and see what those rules are doing, which is of course important if you have a crew of 100 different field engineers that all created their own rules. With the Waylay rule designer, it's actually very easy to see what the rule is doing, and you don't have to dive into the code to understand what it does. So in that sense, the Waylay platform focuses a lot on explainability of the rules. It's also a tool that can allow you to scale up, in the sense that we have also features that can automatically instantiate rules when new assets are being brought into production. So all of these scalability features are supported with the Waylay platform. It's one platform that can run on any cloud. It's completely cloud agnostic and leverage the underlying cloud infrastructure that you may already have. But the main benefit is that it really allows the different stakeholders within a company, whether it's the field engineers, whether it's the marketing team, whether it's the product team, to collaborate in a very efficient way and a scalable way. Okay, that's it for today. Like I said, if you have questions for me, let me know. Send me an email at tom@waylay.io. I'm going to quickly look here at the Q&A section. I don't see any questions so far, but feel free to send it to me afterwards if you're interested in the Waylay platform, or if you want to talk about your specific use case on how Waylay could help. Let me know. We're here to help, and I hope you found it interesting. And I'll keep the Q&A session open for a few more minutes, just to see if there are any people that have questions. Okay, I see no further questions, so let's end the presentation here. Thanks for your participation, and let's hope we see each other somewhere in real life next year after the COVID-19 situation. Bye-bye, and have a great day.